So in this video, we're going to do another example of a hypothesis test that's actually related to our previous example. So we're going to talk about seeing how example 2 would change if instead they just wanted to see if the approval rating of the president had changed. So what that really means, I'm trying to say here, is that the data that we collected is going to be exactly the same. The only thing I'm changing is the goal. Instead of wanting to see if his approval rating had increased, we just want to see if his approval rating has changed. So as soon as I see that word changed, what would it mean for his approval rating to have changed? It means it could have gone up or it could have gone down. So what I'm going to do is go through the steps that do change and sort of circle the pieces that change. So if we first look at our hypotheses, we will actually see our first change. We're still going to have our P as our symbol, and we're still going to have that 39.9%, his current approval rating in the February time frame. But what's going to be different for us is that instead of having that greater than sign, we're going to have that not equal to sign, because that's what it would mean if it had changed. The null hypothesis is still the same. Again, still the same symbol, the same number, and that one will always have an equal sign in it. If I look at step 2, that decision rule that we do, I'm still going to use the same significance level. So for that reason, step 2 here is going to be exactly the same. So there's no changes at all in step 2. Next, let's talk through step 3. So looking back here, we're still taking the same sample. So we're still going to have 1,500 people sampled. We're still going to find that 651 of those 1,500 approved of the president. So p hat is still going to be 0.434. I'm not changing my sampling method, so it's still a stratified sample that doesn't have any bias known. And our n is still 1,500. And I didn't change the number in my hypothesis I had up here. So all of the conditions will stay exactly the same. So then moving over to our z, p hat is still 0.434. p0 is still 0.399. And n is still 1,500. So we're still going to get the same test statistic as well. So what that means for us is that step 3 doesn't change either. All right, next let's talk through step 4. So looking through how we did the p-value calculation, we took our z, put it on our picture, and then we had to ask ourselves what was our alternative hypothesis. First, we started by asking if it was a one-tailed versus two-tailed test. Originally, we were only looking in one direction, so we had a one-tailed test. But now, we have that not equal to sign, which does actually mean we have a two-tailed test instead. So let's look at how that changes what we're doing. So remember, z is centered at 0. It's always measuring how many standard deviations away we are. So my scale is always going to look the same here. And so first we put our z of 2.77 on here. And then again, this is when we're asking ourselves what that alternative hypothesis sign is. So as soon as I have this not equal to, that's going to change my picture. How is that going to change our picture? Well, let's go back and look at the definition of a p-value. So a p-value is the probability of observing our data or more supportive of HA. This is the part we need to talk about. What does it mean to be more supportive of HA? Well, we already know we're going to have the idea of two sides shaded here because it's a two-tailed test. But let's now talk more about what this 2.77 was telling us. The fact that it was positive told us that we were 2.77 standard deviations above where we expected to be. And when I do a one-tailed test, that direction is very important to me because I'm only looking in one direction. But when I'm doing a two-tailed test, I don't care if you're above the mean or if you're below the mean. It makes no difference to me. So if I'm going to look 2.77 standard deviations above the mean, I've also got to look at being 2.77 standard deviations below the mean. So I'm still going to have this piece over here shaded, that little right tail, but now I'm also going to have this little left tail to worry about. So that changes my picture and thus changes my probability or p-value that we're going to do. So our actual p-value now means I need to actually find these two separate probabilities and then I'll add those together. This piece is exactly what we found here. And so I'm actually going to write out that piece for us. And I'm going to do it down here. So for that piece, we did 1 minus the 0.9972 since it was shaded right. But now I also need to find this shaded area. So this shaded area is shaded left. So for this one I can go straight to the table and look up that negative 2.77. And what I should find in my table is a probability of 0.0028. So this piece here is sort of the extra that we're changing for the p-value. And so if I do that math, something's going to happen that's not a coincidence. What we should notice is that those two pieces are exactly the same. That's happening here because remember the normal distribution is symmetric. And so being 2.77 above the mean or higher is the same as being the 2.77 below the mean or left or lower than that as well. So those two pieces will always be the same. So if you want to make your life easier on this calculation, we can just double one of those pieces to get our two-tailed p-value. And since a p-value is a probability, it does have to be between 0 and 1. So if you accidentally doubled the wrong piece, you would kind of know. So the 0.0056 would be our p-value. So that is different than what we had. We have this double the p-value going on because of it being two-tailed. Now if we compare that to our decision, so we have to now check to see if our new p-value that we calculated, is it less than 0.05? Yeah, so we're going to get the same decision here, so this is not different. We're still going to end up rejecting the null hypothesis here and instead believing the alternative hypothesis. And now let's talk about how that interpretation is going to be a tad bit different. The first part is going to be the same, as our alpha was still 5% or 0.05. We rejected, so there is still statistically significant evidence. To support. But now the last piece was our alternative hypothesis in words. So this is a little bit different because we had a different alternative. So there is evidence to support that the president's approval rating changed from February of 2019 to May of 2019. So right now our main difference here is that we have this word changed. But I'm actually not quite done. So if I read that statement and imagine you were actually telling the president, so your approval rating has changed. I'm going to guess that he's not going to be satisfied with that answer. If something has changed, I would also like to know how did it change. So I'd also like to be able to tell you in how it changed. So, in fact, it what? Either it has increased or it has decreased. Now, how do I know? Now is when I pay attention to the fact that my z that I calculated here was positive or to the right of the mean. Because if I'm positive, right, I am 2.77 standard deviations above or higher than what I expected to be. So I in fact know not only did it change, in fact it has increased. And again, how I know that, because my z was positive, which means we are above the mean. And remember, our mean is what we're talking about here. Okay, so that's sort of how that example would change if all we did was change that alternative hypothesis. So what you should see is it changes your p-value. Here it doubled it. And it did change a little bit of our interpretation that we worked with there as well. So just to see if we understand how p-values come about, what would my p-value have been if simply my HA was p is less than 0.399? That should say, so 0.399. What would that look like instead? Well, let's imagine what our picture would look like. If I go back to my other one-tailed picture, right, my z would still be the same, but instead of shading to the right, I would shade to the left. So what value would I have gotten if I would have shaded left? Well, I would go straight to the table and look up that 2.77, and I would simply get that 0.9972. Just because your picture would be shaded left instead of shaded right. So now you can see how important it is to understand your alternative hypothesis sign, because it does dramatically change your p-value. Finally, I was going to show you how you can verify these p-values in Statcrunch as well. So let's go ahead and do that here real quick. So first, you just want to get logged in to your Statcrunch, and here's the page we will be at. First, I'm just going to open a Statcrunch page. And I don't actually need to enter anything here to do this test. So what we're going to do is follow the directions. So it says stat, proportions, one sample with summary. So stat, proportions, one sample with summary. Here I'm going to enter in my data first. The number of successes that we get were how many people actually approved of the president in our sample. So we found that 651 of them approved of the president out of that 1,500. So what you'll notice is these are the two numbers that we had to divide to calculate our p-hat. Next, we're going to be doing a hypothesis test, so I'm going to leave that as is. And then we're going to make sure we put in the correct number for our null hypothesis. So ours was 0.399. And then I can choose my alternative sign. So we have the not equal to, the less than, or the greater than. So I'll do the greater than first, since that was for example 2. And hit compute. So here's our output, which you're going to see kind of working backwards here. There's our p-value of 0.0028 that we got for example 2. There's our z of approximately 2.77 that we calculated. This standard error that you see here, that was the denominator when we did the test statistic calculation here. So our 0.012644 value is what they got here. There's our value of p hat. And then of course they spit out your hypotheses, so you can kind of make sure that those match what your step 1 looks like. So if all I do is go out here and change this to that not equal to, the only effect it's going to have on my output is my p-value. Nothing else is going to change. So notice how our p-value is now that 0.0056 that we just did with example 3. It's double what it was. Finally, since we also talked about what would happen if it was a less than sign, you can see again that it just changes your p-value to be that 0.9972. So if you're going to use Statcrunch to double check your math, be very careful of making sure your sign is pointing the right way, otherwise you're going to have a very different p-value than you should. But keep in mind that on your exams, you're not going to be using Statcrunch, so make sure you do know how to do this by hand as well.